In problem 5, for which the sound should be better because I finally turned on the correct mic. In problem 5, we have a mouse. It has a mass of 0.1959 kilograms. It starts off with an initial Y position of 87.4 meters. It has an initial velocity of 0. It has a final velocity of 5.377 meters per second, and it has a final position that we're going to call 0. And so the question is, how much work is done on the mouse by air resistance? Well, the work done by non-conservative forces is going to be delta K plus U, right? The change in potential and kinetic energy over from the top of the mine shaft to the bottom of the mine shaft is going to be the work done by friction due to air, right? The air resistance. So the change in kinetic energy, initial kinetic energy is 0, so the change in kinetic energy equals the final kinetic energy, which is 1/2 mv final squared, right? The initial kinetic energy is 0. The change in potential energy is, you start off with potential energy and you end up at 0. So the change in potential energy is minus mg y initial, because there is y final is 0, so that part is 0. And so the work done by non-conservative forces is just this expression, minus mg y initial. And that's it. That's the work done by air resistance as the mouse falls from the top of the shaft to the bottom of the shaft. And that's it for this final problem.